Hello everyone, welcome to the class 12 of NCRT textbook in chapter 5. So we are going to see a small portion in chapter 5, that is bonding in metal carbonyls. So do you know what is carbonyl? We have learned about ligands, different type of ligands, and we have came across this CO as a ligand or carbon monoxide in common terms. But when these are becoming the ligands, they are known as carbonyls. So metal can interact with the carbonyls ligands to form stable coordination complexes. And there is a wide class of different carbonyls produced with different metals. So we will see some of the structures of this kind of carbonyls, as well as we'll see the bonding that is happening in carbonyl coordination complexes. So we will tell that is a synergic bond. The bond, already present bond, is enhanced by some other interaction between the orbitals. That is a synergic kind of, that is synergy. Synergy is something that is enhancing the already existing interaction. So synergic bond is present in the case of carbonyl compounds. So we can tell that the metal carbon bond possesses both sigma and pi character. Sigma bond is produced when lone pair of electrons in the carbonyls. In the carbonyls, lone pair of electron is donated to the metal's d orbital. We will get the sigma bond. And pi bond is formed when a pair of electrons from the filled d orbitals of the metal is donated into the vacant antibonding orbital of the carbonyl group. So these two interactions, the sigma bond and the back pi bond, sigma bond is from the carbonyl to the metal d orbital, and the already filled d orbitals of the metals electron will form a pi bond with the antibonding orbital, pi star orbital of the carbonyl carbon. So the carbon in the carbonyl group and the metals d orbital is having this kind of two interactions, sigma and pi bonds. So the already present sigma bond is enhanced or made more strong when pi bonds are formed. This is happening because this carbon has an antibonding orbital, pi star orbital, which is vacant. So this causes a synergic effect and it strengthens the bond between the carbonyl and the metal. So carbonyl ligands forms a variety of complexes with different metals. So we will see some of the structures of this compounds. First we will see tetracarbonyl nickel. Its structure is like this: 4 carbonyls and 1 nickel metal. So nickel is at the center of a tetrahedral and all the carbonyl groups attached at the 4 corners of the tetrahedral. Now coming to pentacarbonyl iron. So iron is the central metal atom and there are 5 carbonyl groups. They are having this structure, a trigonal bipyramidal. That means the iron is at the center of a triangle whose 3 corners are occupied by the carbonyl groups and two carbonyls are arranged like this, so that one is above the plane of this triangle and one is below the plane of this triangle. So this is the structure of pentacarbonyl iron, which is trigonal bipyramidal. A triangle is there and below and above 2 apex are there to form a pyramid, 2 pyramids. Then coming to hexacarbonyl chromium. The structure is octahedral. So we have seen the octahedral structure. That is, chromium is the center and four corners of a square is occupied by four carbonyls in the plane of the metal itself. And two carbonyls are not in the plane. One is above the plane, one is below the plane. Now coming to the next representative molecule, that is decacarbonyl dimanganese 0. Decacarbonyl means deca means 10. There are 10 carbonyls and dimanganese. 2 manganese are there. So this is like 2 square pyramids connected by a manganese single bond. The structure is like this, and manganese is this here, and in this plane like this, if we are considering this plane we are drawing, in the plane that is perpendicular to the screen there are 4 carbonyls. Two are behind the screen, 2 are in front of the screen. So this will be the proper structure. And one will be in this plane like this, 1 carbonyl. And so we will get a square pyramid. Square is in the perpendicular to the plane of this screen, and one is in the plane. And they will form a square pyramid like this. And this is single bonded to another such square pyramid of manganese and carbons. So this is the second square pyramid and one CO. So this is the structure of decacarbonyl dimanganese. Structure will be like this. 2 square pyramids are connected via a manganese single bond. And now coming to the next representative compound, that is octacarbonyl dicobalt. Structure is like this. Octa means 8. 8 carbonyls are there. Dicobalt, 2 cobalts are there. Though this structure is like this. Here, 1 carbonyl will be below the plane of the screen and one will be towards the front of the carbonyl, front of the plane of the screen. So it is somewhat like a tetrahedral with apex being the cobalt ion. And this is connected to the second such set of tetrahedral through a single bond. And the exception here is there is 2 carbonyls are here in this molecule such that they are common to both these cobalt atoms. This is known as bridged carbonyls. So some ligands will form bridged compounds. So this is known as a bridged compound. So 3 carbonyls are each therefore cobalt or each cobalt ion. Other than that, 2 are common to both as a bridged compound. This is the structure of octacarbonyl dicobalt 0. So keep in mind for cobalt, CO2CO8 structure is different. It is having a bridged carbonyl group. So it's having 2 bridged carbonyl groups. And nickel carbonyl, tetracarbonyl, nickel has a tetrahedral structure with the nickel at the center of the tetrahedron. Tetrahedron is like this. And at the center, apex is another carbonyl group. Center of the tetrahedron is occupied by the nickel. And for pentacarbonyl iron, it is having a trigonal bipyramidal structure, and all the structures given is here. Hexacarbonyl chromium has a octahedral structure, and we have explained detailed about the other two complexes, decacarbonyl manganese and octacarbonyl dicobalt. I hope everything is clear in this video. Thank you for watching. Happy learning.